freebeats.io, freebeats.io, freebeats.io.
Hi, my babies! Welcome back. This is going to be your very first math lesson on e-learning, and I am so excited. Miss Norris has put so much energy and time in getting this together, so hopefully it goes well for you. After I do this video for you, Miss Norris is headed outside with her kids. I hope you are having plenty of time outside as well, enjoying the sun and just having fun. Now, going places unnecessarily, try to stay away from that if you can, but make sure you are eating healthy, your fruits and vegetables. Make sure you're washing your hands with soap. But I really hope you're enjoying your time. But school has started. Remember, Miss Norris will be putting up 2 videos on Tuesday and 2 videos on Wednesday, and we are going live on Thursday. So today is your first math lesson. Miss Norris is going to review with you in your math packet pages 3 through 5. Okay, once again, I am reviewing some examples from pages 3, pages 4, and reviewing some on page 5. But you are going to be assigned to complete page 5. Now, parents, it is solely up to you on whether or not you want them to complete pages 3 and pages 4, but you are assigned page 5. When you are done with your work, please send me a text or write a comment under the video to say, Miss Norris, I'm done. And please feel free to also leave comments and questions if you need help as well. We are doing page 3, 4, and 5. Miss Norris is just going to review a couple of examples from each page just to kind of help you resharp your memory. But you're going to complete page 5 on your own, okay? And then tomorrow on Wednesday, Miss Norris is going to be teaching you page 7, and you're going to be assigned page 6. All right, so I'm going to stop right there so that there's not too much info. So let's get into the video. Bye.
All right, so you should be on the correct page. These equations that I have on here may not meet, or they may not be exact, but they're pretty much the same equations. We already know how to add, especially we know that when there's a big number and a number that can fit on our fingers, what do? We put the big number in our head and we put the small number on our fingers. But for some of us, we still may be using dots. Use different color. That's fine. But as we went through the year, you know that Miss Norris said, hey, let's kind of get away from using dots and sticks because eventually we're going to get into really big numbers and you can't draw 125 dots plus 136 dots. That's going to take forever. So we're going to do it the way that Miss Norris taught us to do it. So remember, we don't like going side to side when we do our equations. We like doing what? Going up and down. So we have 9 plus 4. And in an equation like this, it is okay to go ahead and put your dots on the side. And then adding them up. And our answer is 13. Okay? And we're going to do the same thing for 7 plus 8. Remember, we can either put the biggest number in our brain and the smallest number on our fingers. So we start with 8 in our brain and then we put 7 on our fingers. And then since we're adding, our numbers get bigger. So we point to our brain and say 8. We have 7 fingers up. So we say 8, 9, 10, 11, 12, 13, 14, 15. Or we can go ahead and use our equation. And so we would have 8 plus 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. We use our dots. 8 plus 7 we found out was 15. All right. Now, 3 plus 2, easy peasy, lemon squeezy. 3 plus 2. For those of us who are still struggling with these, and that's okay too, you can go ahead and you can use sticks. 1, 2, 3, 1, 2, or you could use your dots. 1, 2, 3, 1, 2. Or you can go ahead and write the equation 3 plus 2 and write our dots on the side. And 3 plus 2 is equal to 5. All right. So that is how we would do simple, easy peasy, lemon squeezy. Addition problems. All right. So now we're going to go to the next one. And these are doubles. And sometimes we have an equation that's so much easier than what we think because we don't realize, oh my goodness, this is a double plus 1. And doubles mean it's the same number added. So 2 plus 2 is a double. 3 plus 3 is a double. 4 plus 4 is a double. The same number added 2 times. So let's look at this equation. 5 plus 5 is a double. And doubles are usually way easier to add. So 5 plus 5, we're going to just go ahead and write is 10. So as we look at 5 plus 6, we can think to ourselves, because we know 5 plus 5 is 6. 5 plus 5 is 10. Now I have 5 plus 6. Oh, 5 plus 5 is 10. 6 is only 1 more than 5. So if I had 5 plus 5 is equal to 10, and 6 is only 1 more than 5, I can add 1 and get 11. All right? Let Miss Norris do another problem. Similar to this one. All right. We have 6 plus 6. And then we have 6 plus 7. So remember, doubles are two numbers that are added, that are the same number. So 7 plus 7, 8 plus 8, 9 plus 9, 20 plus 20. It's just the same number added twice. So 6 plus 6, we can consider that a double. And we know 6 plus 6 is equal to 12. All right. So now we have 6 plus 7. When we look at an equation like this, we can think to ourselves, oh my God, 6 plus 6 is 12. 7 is only 1 more than 6. So if 6 plus 6 is equal to 12, and 7 is just 1 more than 6, 12 plus 1 is 13. All right. So now we're going to move on to our whole part. And this is something that we learn probably in December, November, somewhere in there. We learned whole part. And we know that we use whole part when we are using, when we're trying to find missing parts. Or missing things in an equation. So usually we use a whole part when we have an equation with missing numbers, or we have a story problem and we need to figure out something in a story problem. So remember these equations. Whole minus part equals part. Part plus part equals whole. Now, whole minus part equals part is just your everyday subtraction problem. That's literally a regular smegular subtraction problem. Part plus part equals whole is an everyday addition problem. We just didn't know that it was a whole minus a part was a subtraction problem, and that part plus a part was an addition problem. But that's all that is. A whole minus a part equal a part is just a subtraction problem. Part plus part equal whole is just an addition problem. That's all. Your whole is always greater than your part. Your whole can never be smaller than your part. So when we get into your story problems and we're trying to figure out things that are missing, we have to remember that our whole number is always going to be the biggest. All right? It is never going to be smaller than your part. So when you look at your equation, you say, whoa, my part is bigger. Something has to be wrong. So remember these things: whole minus part equals part plus part equals whole, and your whole is always greater than your part. Okay? All right, so if we have an equation where we have 13 minus 4 equals blank, we don't know what the blank is. As you can see here, I went on ahead and I kind of wrote out the equation that I had. Whole minus part equals part. My whole minus my part equals my part. Okay, so I can go ahead and I'm going to use my whole part chart. And remember, Miss Norris taught you this earlier in the year. So we have our whole part chart, and we labeled our numbers. We know that a subtraction problem is my whole minus my part equals my part. So my subtraction problem is 13 minus 4 equals blank. So whole is 13 because I labeled it. And one of my parts is 4 because it's labeled. I do not know my other part because my other part is a blank yellow box. I don't know what it is. So in this equation, it already tells us what we need to do to find the missing number. We need to subtract. So we're going to subtract 13 minus 4. Remember, we always like writing our equations going up and down, not side to side. All right, it's easier this way. And we always start in the ones place. All right, so when I subtract, the first thing I do is circle the bigger number. And in this equation, the bigger number is 4. More on the floor, go next door. When I subtract, I take from the tens and then go back. More on the floor, go next door. Go next door, how many do I take? I take just 1. So what is 1 minus 1? It is 0. When I subtract, I take from the tens and then go back. And I add 10. Now, where did I get that adding 10 from? Well, 110 is equal to 10 ones. So that's where I got my plus 10 from. So now my 3 actually turns into 13 because 3 plus 10 is 13. Now I can subtract because my bigger number is on the top. 13 minus 4 is 9. Now I go to the tens place. I have a 0 and a blank. Well, we know that when it's blank, the number is 0. And we know that if I have the same number, there is no point in circling the bigger number because they're the same number. So 0 minus 0 is 0. So the answer is 9. All right. Here we go. Here we go. Here we go. Here we go. All right. Here we go. I labeled my next equation. 11 minus blank is equal to 3. Okay, well, I know that when a subtraction problem, all it is my whole minus my part equals my part. That's all that means. So I labeled it. Whole minus my part equals my part. Okay, so W minus P equals P. Whole, part. So 11 is my whole. My part is an empty yellow box. And then 3 is my other part. So here we go. 11 is my whole. One of my parts is missing. And my other part is 3. All right. So now you say, okay, Miss Norris, something isn't right. How do I find this answer? All right. Now remember, when we use our whole part chart, and it doesn't just give us the answer, kind of like the first one, like this one, it just gave us what to do. Well, on this one, this is why our whole part chart is helpful. When we use our whole part chart, when we have our whole number and we have one of our parts, we subtract. Okay? One more time. When we're using our whole part chart and we have our whole and one of our parts, that means we subtract. All right? So here we go. My 11 minus 3 is equal to, we don't know. All right? We always start in the ones place. When I subtract, the first thing I do is circle the bigger number. The bigger number is 3. More on the floor, go next door. When I subtract, I take from the tens and then go back. So, circle the bigger number. When I subtract, I take from the tens and then go back. How many do I take? I only take 1 10. So 1 minus 1 leaves me with 0 tens. I have none left because I took the 1. I take from the tens and then go back and add it to my ones place. Why did I add 10? Because the 10 that I took equals 10 ones. So I can't take a 10 and keep it as a 10 in my ones place. Just like I can't take a 1 and put it in my tens place and keep it as a ones. So that's why we take 10 ones and put it in the tens place. And we take 1 10 and turn it into 10 ones because it's kind of like conversion. You cannot keep 1 10. You can't carry it over to the ones and keep it as a tens. You have to convert it into a ones. And 10 ones is equal to 1 10. So we have 1 plus 10 is equal to 11. Now we can subtract because our biggest number is at the top. 11 minus 3 is equal to 8. And now we go to the tens place. I have a 0 and a blank. Well, we know that a blank is equal to 0. 0 minus 0 is 0. So the answer is 8. Booyah! Booyah! All right. Next one. We have 2 plus blank is equal to 16. Now, as you notice now, it's an addition problem. Remember, addition problems is just part plus part equals whole. Okay? A subtraction problem is whole part minus part equals part. And an addition problem is just part plus part equals whole. That's all it is. So we have an addition problem. We need to first label it. We know that an addition problem, it is part plus part is equal to a whole. Okay? That's what we know. So now we can put it into our whole part chart. I know my part is 2. do not know my other part because it's a yellow box. And my whole is 16. All right, Miss Norris, well, how do we find the missing yellow box? I'm glad you asked. We know that when we use our whole part chart, when we have our whole and our part, we subtract. So we have our whole and we have our part. So we subtract. So here we go. 16 minus 2. And we always start in the ones place. All right? When we subtract, the first thing I do is circle the bigger number. The bigger number is 6. More on top, no need to stop. 6 minus 2 is 4. Now I go to the tens place. I have a 1 and a missing number. We know that missing number is 0. So we have 1 minus 0. The first thing I do is circle the bigger number. The bigger number is 1. More on top. No need to stop. All right. And so we know that 1 minus 0 is 1. So the answer is 14. All right. Last problem. We have blank minus 3 equals 11. All right. Well, I know in the subtraction problem, whole minus part equals part. So I'm going to label whole minus part equals part. All right. So I'm going to go ahead and now I can fill in my whole part chart with this information. I don't have my whole because my whole is a yellow box. So I don't have that. My part is 3. And my other part is 11. Now, the difference with this equation is that we have 2 parts. Now, when we have 2 parts, we add. Look at this addition problem up here. 2 parts, we add. Whole and a part, we subtract. So just similar to an addition problem, when you have 2 parts, you add them together. When you have 2 parts, we add. So we have 3 and 11. Always start in the ones place. 1 and 3 equals 4. 1 and 0 equals 1. So the answer is 14. I really hope that this helped. Of course, leave a comment below if you have any other questions. Also, you can contact me on Schoology, as well as sending me an email or a text as well. Like I said, you can definitely always review this video for more help as well. But today your assignment is going to be page 5. And then parents, you can also assign them the addition problems that I showed you previously. So this worksheet, as well as your doubles and doubles plus 1 worksheet. You can show them that as well. So today your assignment is page 5 for math. Miss Norris loves you, and I hope you have a great one. Bye.